In 2010, he got his master's degree from the University of Kansas in applied behavioral science, working with Gregory Batten. Greg was one of my former postdocs and probably the most skilled former postdoc I ever had, who's gone on to do very good things. In 2010, Greg got seduced to Utah State University, and Jeff moved with Greg and got his PhD there in 2016. Interestingly enough, Jeff recapitulated and reversed my experience. I started my PhD program at Utah State University, but then transferred to the University of Kansas, where I got my PhD. Interesting. Jeff came here in 2016, and he's been highly productive throughout his entire career. He currently has 35 peer-reviewed publications, 5 chapters, published in places like Appetite, Clinical Psychological Science, Journal of Behavioral Medicine, Preventative Medicine. The interesting thing about Jeff is when he was working with Greg, he was doing animal studies and had developed models of gambling behavior in rats and was looking at ways to change that behavior and the degree of discounting that they exhibited in some interesting ways that parallel some of the things we do now. When he came here, he got involved with our drug work and brought that history with him. But once we started the new center for the center, and we got some research funds to look at prediabetes, Jeff jumped in with both feet on that, started learning the whole issues of health behavior, and has really been making a big splash there. This year he received 2 R21s, one on tobacco, one on in addressing diabetes. He's collaborating with Jennifer Vaughn on a pilot project that's funded by the CTRHB, looking at medication adherence in breast cancer patients. And if you've had a chance to interact with Jeff, you find him very easy to interact with. When I've seen him interact with trainees, he's a very good teacher. And I'm looking forward to hearing his presentation, using behavioral economics to understand and reduce lifestyle-related morbidity and mortality. Jeff?
Thank you, Warren, for that introduction. I want to define a couple of key concepts, if only briefly, that are going to help frame the rest of my talk. One of them is behavioral economics. And there are a couple of different flavors of behavioral economics, or somewhat different disciplines that fall under the same umbrella term of behavioral economics. There's a substantial amount of overlap between them, but the flavor of behavioral economics I mean here is a hybridized field of psychology and microeconomics, so the study of economics at the individual subject level. We were primarily interested in how individuals or organisms allocate limited resources or their behavior to the different available commodities or reinforcement in the environment. We examine the influence of not only monetary costs, but also effort-based costs, including how much behavior one is willing to engage in to obtain some outcome, as well as delay costs, so how long one is willing to wait to obtain some outcome. Typically, the work is experimental, not observational. That's not to say that we don't do observational research, just that the way we impose costs and look at the influence of that on behavior is experimental. And we typically look at the behavior of individual subjects rather than population-level changes in behavior as a function of those costs. Second term is health behavior, and that's it may be self-explanatory, but I'll define it anyway. But by health behavior, I mean either the omission or commission of behavior that directly impacts health and mortality. So omission, not doing enough of the things that we're all supposed to do to keep ourselves healthy. Commission, doing too many of the things that we're not supposed to do to keep ourselves healthy. And this, between those two categories, that covers a broad swath of behavior, things like tobacco, alcohol, other substance use, dietary intake and physical activity, or sedentary activity that lead to overweight, obesity, different metabolic disorders like type 2 diabetes, as well as other disorders like cardiovascular disease. Also, things like medical screening and prevention, so how often people get screened for different kinds of cancer. Also prevention, relatively small things like how often people get flu shots, all that's health behavior. And a big one is treatment and medication adherence. So once someone has been diagnosed with some disease or disorder, how well individual follows physician-recommended treatment guidelines. My work has focused on two main research areas, both a growing field known as tobacco regulatory science and additional work on what we call intertemporal choice. So intertemporal choice, how individuals value different outcomes and choose between those outcomes that are experienced at different points in time. There's a fair amount of overlap between them, and I'll sort of discuss that overlap as they come up between those research lines. But this latter category, intertemporal choice, I've historically explored in the addiction space, and then over the past several years, my focus has been health behavior more broadly, health behavior other than addiction, which I'll speak about a little bit later. But I'll start with my work in tobacco regulatory science. If you're not familiar with the term, it's an emerging field consisting of essentially research devoted primarily to directly informing public policy regarding tobacco regulation. So with the proliferation of novel tobacco products over the past 10 years or so, not only the thousands of different sub-varieties of e-cigarettes, but also smokeless tobacco products and other tobacco products as well, it's important to generate empirically derived estimates of what potential changes in policy would look like, what the effects of those policies might be. And that's where the role of tobacco regulatory science comes in. And all of this is done with the overall goal of reducing tobacco-related harm, including the reduction in the initiation of tobacco use, encouraging cessation in those who already use tobacco, as well as for those who are either unable or unwilling to quit using tobacco, reducing the adverse health impact for that continued use. And these latter two bullets are what primarily my research focuses on. What are the environmental or policy manipulations that might encourage cessation, and what are the environmental and policy manipulations that might reduce adverse health impact? One of the key measures that we use is behavioral economic demand, which measures the influence of price on consumption of any given commodity. And from that, we can construct a demand curve. And from the demand curve, we can derive two independent measures of demand. One of them is shown here. That's elasticity of demand. And that essentially describes the sensitivity of consumption or purchasing to increases in price. And that provides a measure of value. So if an individual's consumption is very sensitive to price, that is, it declines very rapidly as you begin to increase price, then that's an indication that that individual doesn't value that commodity very much. If in contrast, an individual's elasticity of demand is relatively inelastic, if it's insensitive to price, then that's an indication that the individual values that commodity a great deal because they're willing to defend some initial level of consumption across increasing prices. Oh, I should mention, here, not shown here is a separate sort of independent measure of demand, what we call demand intensity. And that's by proxy sort of a measure of the overall level of the demand curve. So you can consume a lot of something or a little of something, and you could have the same level of elasticity. We measure intensity of demand by typically the y-intercept. So it's consumption or purchasing when the commodity is free or nearly free. Here, the two demand curves converge at that y-intercept, though. How do we measure demand? We can do it hypothetically with hypothetical purchase tasks where participants self-report the quantity of a given product, typically tobacco products in the work that I'll describe, across a range of prices, or we can do it with real tobacco product purchases. Most of the data I'm going to describe today was collected using real tobacco product purchasing for a few reasons, but primarily because the work I'm going to describe examined naive users of the tobacco products that we're examining. So we wanted to make sure that we're providing direct experience with those products so that participants are making informed choices. So most of the studies I'm going to share sort of share the general methods I'm about to describe. So at the beginning of a study, participants are able to sample the different study products that are available in the study. Usually this occurs outside of the lab, so in the natural environment. Sometimes it does occur in the lab, but they'll take products home for anywhere from 2 days to up to a week to use in the natural environment. Then they'll come back. They'll be provided with an experimental income, and that income is proportional to the real-world tobacco use. If they come into the study using a lot of tobacco, smoking a lot per day, for example, then they will receive to spend in the lab relatively more than somebody who smokes less. Then they use that income to purchase real-world supplies of tobacco products across a range of prices. For example, 12 cents through $2 per cigarette. The units that we make available are typically individual units of the product, so individual cigarettes or individual packets of smokeless tobacco. The reason for that is that it provides more granular measures of purchasing, because especially if participants are purchasing for a relatively short period, there are only so many packs of cigarettes they could purchase. So here they're purchasing individual cigarettes or other units of the commodity. Sure.
I totally lost track over the years of what tobacco products cost. Can you give me a sense of a pack of cigarettes?
It's compared to the national average, is incredibly cheap in Roanoke and surrounding areas. It's about our sort of standard market price per cigarette is about 25 cents. Per pack, it's about $5. I think the national average is like $7 to $7.50. But it exceeds $12, $13 in some areas too. So it's pretty cheap here. And that reflects, I think, a number of things, but there are a ton of smokers in the valley. So. Also important to point out, participants can keep any unspent income. So if they receive $30 to purchase tobacco products for, say, the week, and they only spend $20, then they can keep the remaining $10, or they don't have to spend any at all, and they can keep the entire $30. So participants are incurring a real cost for purchasing these tobacco products. So in that way, the procedure was built to be an ecologically valid method because they are incurring costs. Also, in general, these methods were designed to be naturalistic, to be ecologically valid, because even though they're purchasing in the lab, they're purchasing the products in the lab to use in the real world. So they're taking them home and using them the way they would if they purchased them from a convenience store or a tobacco shop. In that way, purchasing in the lab is subject to real-world constraints, things like smoking bans, public perception of different products, et cetera. So in that way, it was built to be naturalistic. One of the first products I looked at is a form of smokeless tobacco called Snus. If you're not familiar, Snus is a low nitrosamine, low carcinogen smokeless tobacco product, which some consider a potentially safer alternative to combustible cigarettes. A note on the safer issue. So if total tobacco cessation is unlikely for some individuals, then regulation could be designed that might make it more likely that those individuals would switch to a potentially safer product. That raises new concerns about whether people who wouldn't have smoked cigarettes otherwise will then begin to use that product. And that's a separate matter, which I'll touch on a little bit later. But if you want to see what's the likelihood that participants will switch to a given product, what the appeal is of that potentially safer product. And the first step in that process is to evaluate how much existing smokers value or like that product. So you'd want any sort of such product to have some abuse liability, some appeal, but not so much that it would garner even greater dependence than we observed for cigarettes. So there's kind of a Goldilocks zone that you might be after. So my question here is, how do existing cigarette smokers who are naive to snus value that product? 44 cigarette smokers with minimal prior snus experience participated. So they were naive to snus. Here are the results. Here we have on the x-axis price of each product, and the quantity purchased is on the y-axis, and both axes are normalized to the level of consumption when the products were free, which is the demand intensity parameter. That's often a useful metric to compare demand intensity between products or between conditions. It becomes problematic and difficult to interpret when the tobacco products you're purchasing differ in nicotine content. Specifically, you might expect more or less consumption of a given product just due to differences in nicotine content, which is not a necessarily meaningful comparison. So visually, we've isolated the elasticity parameter here by normalizing the demand curves to that initial level of demand intensity. In general, we saw greater elasticity for snus, more price sensitivity for snus compared to both cigarettes, and we added an additional comparison product, nicotine gum. If you know anything about nicotine gum, it doesn't have much abuse liability at all. It was kind of designed that way. It's meant to be a replacement product, but not meant to garner much addictive potential. But snus is valued, according to this metric, even less than that. And these sort of ordinal rankings of products across the demand measures was corroborated by self-report liking measures. So they reported not liking snus very much. But what we see is that despite this lower level evaluation, most participants in the study still purchased snus. There was this overall willingness to use and purchase snus, just lower levels of valuation. But if we're looking for a potential candidate product for replacement, snus isn't a likely option. Another area that I examined, one product feature that's eligible for regulation, is cigarette filter ventilation. So, brief history lesson. The majority of commercially available cigarettes available in the US and elsewhere feature ventilated filters, and this comprises perforated rings around the filter's tipping paper. The purpose of ventilation was initially intended to produce a safer cigarette by diluting mainstream cigarette smoke so that every puff from a ventilated filter contains a larger proportion of air to smoke than a puff from an unventilated filter. And these became began to become popularized in the 1960s and 70s, and the popularity continued to rise through the 80s and 90s. But what's interesting is that even though they were intended to produce a safer cigarette, there's substantial evidence now that instead it made cigarettes more harmful. And it's for a few reasons. One of which, primarily, is that the evidence that filter ventilation reduced tar and nicotine yields was mainly from machine smoking measurements. Humans, when you give them a cigarette with reduced nicotine yield, they don't smoke like a machine. They'll find ways to compensate for that reduced nicotine yield, including things like taking more puffs per cigarette, taking longer puffs, taking deeper puffs, holding the smoke in more, or even more obviously, smoking more cigarettes per day. So if you consider, so nicotine by itself is certainly not good for you. It poses its own unique risks, but by far the most harmful constituent of combustible tobacco is what's in the smoke. So what this putative harm reduction strategy had effectively done was increase exposure to the most harmful constituent of combustible tobacco. And if you track sort of epidemiology of different kinds of lung cancers, they kind of track pretty well with the rise in popularity of filter ventilation as well. So all of this makes filter ventilation a pretty eligible candidate for regulation, either a total or a partial ban. But also smokers report, especially those who smoke ventilated cigarettes, which are, to some extent, the vast majority of commercially available cigarettes, they report not liking unventilated cigarettes very much. They report the experience as being too harsh, the smoke is too irritating, it affects the character of the smoke. So our question was, how would a ban or a modeled ban affect the abuse liability or the addictive potential of cigarettes? This is a small pilot study. 15 cigarette smokers of light cigarettes participated. And this was, again, pretty small sample, but it was a pilot study that allowed us to secure additional funding to study this phenomenon. Participants sampled study cigarettes for a few days, and the way we manipulated the product design was pretty low-tech, but it was effective. Essentially, we just taped up the filters using tamper-evident tape. For unventilated cigarettes, we took the participant's usual cigarette and then located the tamper-evident tape around the filter ventilation holes, and in testing, this produced about 95% or greater airflow blocking. For control cigarettes, there were also participants' usual brand, but we located the tape about 2 millimeters away from the ventilation holes. And this controls for visual appearance and tactile sensation when smoking, and this effectively produced no change in airflow. And after they sampled study cigarettes, participants came back in to complete 3 different kinds of purchase sessions. In 2 purchase sessions, only 1 cigarette type was available, either unventilated or ventilated cigarettes. So in the unventilated session, this models a regulatory environment in which filter ventilation has been banned entirely. What we see, interestingly, is that no difference in demand when either cigarette was available alone. However, in a 3rd session type, in which we examined preference between cigarette types. So at any given price, both cigarettes were available at the same price, and participants could choose to purchase either of those or neither of those. So it's an assessment of preference, but within a demand context. We saw overwhelmingly greater demand for ventilated control cigarettes in that choice context. So this preference was also evident. We asked them using self-report liking measures, that preference was evident there as well. But in a demand context, it's interesting. What this says is no matter how much participants preferred those ventilated cigarettes, if unventilated cigarettes are the only game in town, they'd likely smoke those with the same frequency as the preferred type, if again, that's the only thing available. And that suggests that a total ban on filtered ventilation may not effectively reduce cigarette consumption. Currently following up on this finding, with not only larger sample sizes, but also under conditions in which a greater range of tobacco products are available, including products that may be less harmful and perhaps more palatable than unventilated cigarettes, so that if there were a ban on filter ventilation and there were more palatable options in the market, what would consumption look like then? Another class of products of ever-increasing popularity and scrutiny is e-cigarettes, which are important to examine. E-cigarettes are electronic nicotine delivery system, vaporize a liquid nicotine solution for purposes of inhalation. And again, they're considered by many to be a potentially safer alternative to cigarettes, although estimates of how much safer vary wildly, and I think it depends on the manufacturer and various e-cigarette parameters as well. But our question here was, again, how do naive users value e-cigarettes? But also, how do e-cigarettes substitute for combustible cigarettes? wrong way. And substitution in a behavioral economic context is operationalized as increases in consumption of a price constant product, here product B, as you manipulate the price of another product. So here we have products A and B. We're changing the price of A on the x-axis, and we get decreases in consumption of A. But price constant product B, we get increases in consumption of that. So that's some evidence of substitution, some evidence of a functional relation or a functional equivalence between those products. And the degree of that effect or the absence of that effect measures the likelihood that users will switch to a given product. And also it possibly forecasts effects of regulation. That is, if regulation were implemented to essentially make a given product unavailable, whether through taxes or a ban or other means, then we can get informed estimates of where consumption might go. So in an initial study, 25 cigarette smokers who were naive to e-cigarettes participated. They were provided with a tank-style e-cigarette for use during the study. And this is it's kind that requires refills of a liquid nicotine solution. And they took home, so e-liquid, they took home some of the e-liquid and sampled it over a few days, and then they came back to complete several purchase sessions. 2 purchase sessions were, again, those products alone. And price, again, is on the x-axis, and the quantity of each product purchased is on the y-axis. And I should mention e-liquid here is in half milliliter units. So these are individual cigarettes in black, but half milliliter units of e-liquid. And half milliliter units was what was made available to participants, and that is relevant because at the nicotine concentration we examined, which was 24 milligrams per milliliter, the amount of total nicotine in half milliliter of e-liquid is approximately similar to the total nicotine in cigarettes. So total nicotine is approximately matched in that way. But here in the alone sessions, we saw lower levels of demand overall for e-liquid, both higher elasticity and lower demand intensity for e-liquid compared to combustible cigarettes. And in a third session type, a second session type, that difference was even further magnified. So the divide between those products was increased. Additional session type, we examined how well e-liquid substituted for combustible cigarettes. So here on the x-axis is price of cigarettes, and then cigarettes is in the closed squares, the black squares. And then we look at what happened to price constant consumption of e-liquid. And we see some moderate substitution effect, but far from perfect substitution. Perfect substitution would essentially be an X up there. And in a fourth session type, we examine the inverse substitutive relation. So now we're looking at not how e-liquid substitutes for cigarettes, but how cigarettes substitutes for e-liquid, and we see no substitution effect. That is, the consumption of cigarettes remain constant. So overall, we see this initial period of e-cigarette exposure, something that models the initiation of e-cigarette use, is apparently characterized by, overall, again, a willingness to use these products. We saw virtually everybody in the study purchase e-liquid in substantial quantities. They were experimenting and trying it, but overall, we saw lower levels of valuation for e-liquid. And we also saw this asymmetrical, imperfect pattern of substitution where e-liquid substituted for cigarettes, but cigarettes did not substitute for e-liquid. On the topic of substitution, one important factor to consider about substitution is that it may be influenced by a number of variables. One of those variables is e-cigarette nicotine strength. So e-cigarette products are available in a broad range of nicotine strengths, all the way from 0 or a placebo dose, all the way up to 50 milligrams per milliliter. And nicotine strength is one big design feature that's eligible for regulation. In the US, e-cigarette nicotine content is relatively unfettered, but in other countries it's been regulated pretty heavily. So like in Canada and Australia, at one point no e-liquid or e-cigarette product containing nicotine could be sold. In places like the UK, maximum nicotine content has been capped at 20 milligrams per milliliter. So our question was, how does nicotine strength impact the efficacy with which e-cigarettes substitute for combustible tobacco? And this was actually a study led by Derek Pope. We examined 25 cigarette smokers who were mostly naive to e-cigarettes. There were a few people in there who had some minimal prior recent experience, but for the most part, naive users. And like the prior study, they were provided with a tank-based e-cigarette in the study. They used it to sample different nicotine strengths for several days prior to purchase sessions. Here are the results. These are graphed a little bit differently than in prior studies for clarity. So on the left panel are cigarette purchases as we manipulate the price of cigarettes, and in the right panel, this is the price of cigarettes and consumption or purchasing of e-liquid at different nicotine strengths. So what we're looking for evidence of substitution are positive slopes, and the more positive the slope, the more evidence we have of substitution. If I could tease out that substitution effect and show only the slopes of those e-liquid curves. So this is e-liquid nicotine strength on the x-axis and that substitution effect on the y-axis. So that's the slope. The greater the slope, the stronger the substitution effect. We see is that substitution is monotonically related to nicotine strength, with greater nicotine strengths producing greater substitution. So what this suggests is that restricting nicotine strength by regulation may limit e-cigarettes' capacity for harm reduction because it may reduce the likelihood that existing smokers will want to switch to e-cigarettes. This is also a little bit consistent with epidemiological data in which smokers who have recently transitioned to e-cigarette use initially prefer very high concentrations or strengths like 24 milligrams per milliliter, at least at first. And this effect was interesting enough that it allowed me to get additional recent funding from the FDA to look at this more broadly and more systematically, because that was a relatively small study, and there were mostly naive users. The question now is, if you look at it more broadly in both naive e-cigarette users as well as dual cigarette and e-cigarette users, people with plenty of prior experience, then you may get different results. Because again, epidemiological data suggests that dual users and people who've already switched, eventually they titrate their dose down to much lower, or their strength down to much lower levels. So something else may be going on with that population that needs to be examined. Another important design feature for e-cigarettes is flavor. So e-cigarettes are available in a broad range of flavors, including desserts, candies, tobaccos, cola flavors. There's evidence that flavor availability may be an important feature in e-cigarettes product efficacy for smoking cessation. But another big concern is that flavor, and there's data to support this, that flavor availability may be driving youth and adolescents to consume e-cigarettes, especially those who never would have smoked otherwise. So that's another concern. So what to do with flavors is a relatively complicated issue from a regulation standpoint. But the question here is, in a demand context, what would happen if flavors were restricted? So this is an online study. Participants were 327 users of tank-based cigarettes, and they were stratified by their cigarette smoking status. Either they were former cigarette smokers or current cigarette smokers. So the former cigarette smokers, they have transitioned to entirely e-cigarette use, and the current cigarette smokers were therefore dual cigarette and e-cigarette users. And they completed hypothetical e-liquid purchase tasks. So here they're hypothetically reporting the quantity of e-liquid they purchased across a range of prices. Under two conditions. One, flavor was either unrestricted, so a broad range of flavors were available, or flavors were restricted, only tobacco flavors were available. And these are the flavors that they could choose from in both tasks. In the unrestricted task, they could choose from 20 possible flavors, so 2 to 4 flavors from each of 9 categories. And in the restricted task, they could only choose from 2 tobacco flavors, so classic or cigar. So this latter task models a regulatory environment in which flavors have been severely restricted. These are the results with e-liquid price, again, on the x-axis, and the quantity of e-liquid bottles purchased on the y-axis. In former smokers, we see this reduction in demand for e-liquid when flavors were restricted. So those restrictions reduced both intensity and elasticity of demand. But interestingly, in dual product users, we see no similar effects. So overall, we saw greater levels of demand, but no differentiation between the two conditions. So this is some preliminary evidence that the effects of flavor restrictions would differ across subpopulations of tobacco users. And one follow-up question then becomes, is this reduction in demand a good thing or a bad thing? If flavor restrictions reduce consumption of e-cigarette products and behavior or consumption doesn't migrate back to combustible cigarettes, that's a good thing. Because any proponent of harm reduction still wouldn't say that e-cigarettes are good for you. Ultimately, the better thing is total tobacco cessation. But if restrictions reduce e-cigarette demand and make it more likely that participants may relapse to cigarette smoking, that's potentially a bad thing. So I think more work in this area is warranted, and specifically in a substitution context. So I've been talking a lot about tobacco stuff, but most of my work recently has focused on intertemporal choice. Yes?
Before you transition, can I ask you a question?
Sure.
So firstly, over what period of time are the subjects carrying out these experiments, making these choices?
So this, right, so this was an online study, so this is a little bit different. This happens over the course of maybe 20 to 30 minutes. The other procedures I discussed previously, these procedures share similar timeline typically. If it's a single session, so these were 4 different session types, right? So in one session, one strength was available, and a second session, another strength. So there are 4 total sessions here. But in between there, they're sampling individual nicotine strengths. So they'll sample that week's nicotine strength, come back after a couple days, and then purchase for a 5-day period, and then repeat the
So we're
process.
A couple weeks.
Yeah.
So, all right, so then to the question I really wanted to ask, and you, maybe you're going to get into this the other part, but I'll throw it out there. Because of the known effects of the nicotine and smoking on satiety and related to obesity and so forth, I'm just wondering if you picked up on anything that could be a confounding variable in choice here for some of these things as related to the perceived consciously or unconsciously, I guess, effects of the subject on their eating behavior, leading to changes in preference for the product type of nicotine product.
Interesting. So as they're getting more nicotine exposure in the study?
Yeah, if they're going, from an e-cigarette or a flavored cigarette, or I'm just trying to think of the various combinations, that might they respond differently? Might the effects on their suppression of desire to eat and so forth be noticeable by them over a period of a couple weeks they're participating in the study and affect their choice for the nicotine product?
Be noticed by them as a positive side effect?
I can think about going either way. Maybe.
Possibly.
Yeah, I'm not sure.
Possibly. We don't, so all these are existing cigarette smokers, so we're not providing exposure to nicotine or tobacco to people who don't normally use cigarettes. And what we see typically is, at least in the studies that I've done, when we're providing additional access to e-cigarettes, that we just see some a little bit of reduction of cigarette consumption. If they're purchasing other products, we just see a little bit of reduction of cigarettes. So I don't know how much more nicotine they're consuming compared to what they normally consume outside of the lab during the study. If they are consuming more, it's probably not a ton more, but there may be some unmeasured effect like you're describing. Yeah.
Yeah, I guess we'll come back to it later, but I'm just kind of curious about the method of delivery of the nicotine, whether the effects on other behaviors, including eating behaviors and desire for food, are differentially affected based on that. So.
Yeah.
There's a paper published in New England Journal of Medicine by Ghani and Hasekani et al. Ghani down at Big Forest. And they looked at the low nicotine containing cigarettes, they substituted them, and they observed weight gain, even though these people were smoking tobacco but had low nicotine. So it's suggesting that nicotine may be the driving factor in suppression of weight gain, and when you remove nicotine, it popped up.
That's interesting. I don't think we even, in at least a lot of my studies, I don't think we even collect weight. So I don't know, we wouldn't be in a position to measure things like weight change. It may be interesting to include. Yeah. Because we certainly measure eating behaviors in other studies, so it would be kind of interesting to combine the two. Fast forward here. Okay, so transition, kind of a clunky segue, but this is it. So intertemporal choice, this is how we value different outcomes delivered or experienced at different points in time. And I'll start off with tobacco-related studies to provide something in the way of a segue, but I've also studied other health behavior and conditions as well. So one form of intertemporal choice is delay discounting, and by delay discounting, I just mean the devaluation of delayed consequences. So devaluing something as a function of the delay until it is experienced. So temporally proximal outcomes have more of a behavioral impact or valued more than more temporally distant outcomes. And this, to some extent, is true for everybody. We all discount the future to varying degrees, but there's an enormous amount of heterogeneity, which is interesting to study, but unfortunately can lead to some pretty maladaptive health behavior. So we typically measure discounting, just a brief overview, but providing choices between a relatively small, immediate reward, typically money, because money is a universally valued reinforcer, and a larger delayed reward. So for example, $50 now or $100 in 6 months. And across trials, across choices, we can titrate different task parameters so that we can arrive at a value of discounting. We can construct a discounting curve. These are two prototypical discounting curves for a given outcome where subjective value declines with increasing delay for both commodities, but much more so for one than the other. So we have, if we take discounting as a measure of impulsivity, the shallow discounting curve is less impulsive because they're less biased toward immediacy. They have a greater ability to delay gratification. And the measure used most often, we can fit observed data using a hyperbolic equation, and the free parameter k provides a measure of the steepness of the curve. So high k equals greater discounting, low k equals less discounting. What we know from quite a few years of research is that high rates of discounting are cross-sectionally associated with a very wide range of health behavior, as well as the outcomes of that behavior, including, of course, substance use, but also diet and exercise, as well as different diseases or conditions, obesity, type 2 diabetes, binge eating disorder, and bulimia. Also medical screening, how often you get mammograms, how often you get pap smears or prostate exams, even how often you go to the dentist is associated with delayed discounting, as well as medication adherence in both type 2 diabetes and hypertension and hyperlipidemia. So it's a pretty broad phenomenon, and as I mentioned a moment ago, delayed discounting is associated with smoking. These are data from one of the foundational studies. This is discounting of $1,000, and we see greater discounting for current smokers compared to both never and former smokers. And sort of aid in interpretation of later data, I'll sort of extract the K value. I'll present corresponding K values. So this is, you can think of it as a discount rate. This is the natural log of K. We log transform them typically because they're not normally distributed. But higher values still mean greater discounting. So we see greater discounting in current smokers compared to both former and never. So all that's pretty well established, the relationship between cigarette smoking and delayed discounting. But what about e-cigarette use? Not a whole lot of work is examined e-cigarette use and delayed discounting. What has been published, one study showed a difference between users and non-users, one didn't, and one was sort of mixed internally. So I wanted to examine this topic more thoroughly. And specifically what makes, to me anyway, this most interesting is that e-cigarettes are widely believed to be less harmful than combustible cigarettes. Whether or not they are actually less harmful is sort of immaterial, but public perception is that they are. About 50% of the general population presently consider e-cigarettes to be at least somewhat less harmful, and about 80% of e-cigarette users consider them to be less harmful. So what those perceptions of relative safety may effectively do is increase the breadth of user type of e-cigarettes, increases the number and type of people who are using e-cigarettes. So if more types of people are using them, because there's generally less concern about their health effects, then discounting may be less influential or less associated with use of these products. So we hypothesized either a weak association with discounting or no association with discounting. This was an online study, so 972 current or never e-cigarette users, and they were stratified by their cigarette smoking status. So either they were current, former, or never cigarette smokers. There's a missing cell up here. The combination of current e-cigarette users and never smokers was not included for a couple of reasons, but mainly they aren't very prevalent in the general population. It's not often, at least among adults. Among youth, it's more of a concern, but among adults, it's not common that you find somebody who currently uses e-cigarettes who has never smoked. So the clinical utility of studying that subpopulation wasn't clear, so I omitted them from this study. Discounting was assessed cross-sectionally at time 1, so at a baseline, as well as at follow-up at time 2, 6 months later. And there's no intervention between these two. We're just looking at naturalistic changes in tobacco consumption. But at time 1, we can get a cross-sectional comparison of delay discounting in current and never e-cigarette users. And then at time 2, we can see how delay discounting at baseline predicts changes in the trajectory of smoking and e-cigarette use. These are the cross-sectional results from time 1. These are the main effects. We saw significantly greater discounting in current e-cigarette users compared to never. And in cigarette use, we saw greater discounting in current compared to both former and never smokers. But the effect size for e-cigarette use was much smaller. E-cigarette use only accounted for about 0.5% of the variance in discounting, whereas cigarette use accounted for about 3% of the variance. And that's consistent with the hypothesis that the association between e-cigarette use and discounting is going to be weaker than that observed for cigarettes. if we break apart the planned pairwise comparisons, this is cigarette use on the x-axis, discount rate on the y. Never e-cigarette users are open squares, current are closed squares. The take-home point here, there's a lot to digest, but if you compare these three groups, these people are the ones who are former smokers who have entirely transitioned to e-cigarettes. So you could say that e-cigarettes help them quit smoking. They are precisely intermediate between never smokers and current smokers who have never used e-cigarettes. So what that suggests to me, and they're not different than either, so that weird middle ground, that gray area, suggests to me is that e-cigarettes may facilitate smoking cessation in a subset of the population who may have not valued their future enough to quit otherwise. And I think that's worthy of future study. If we look at the prospective results, again, this is 6-month follow-up. We're not intervening during that time. We're just looking at naturalistic changes in tobacco use, cigarette, and so at 6-month follow-up, whether they were cigarette or e-cigarette user was defined by 30-day any use. So if they used either product at all, then they were a user of that product. This is discount rate on the x-axis, and then the predicted probability of cessation on the y-axis. This is for people who were current smokers at time 1, at baseline. And we see discounting predicted, lower levels of discounting predicted greater probability of smoking cessation at time 2. And for those who were former smokers at baseline, we see a somewhat more visually striking effect in that higher levels of discounting predicted greater probability of relapse at time 2. For e-cigarettes, we don't see any such effect. And again, this is consistent. This is for either cessation of e-cigarettes or initiation of e-cigarettes. And this is, again, consistent with the hypothesis that e-cigarette use is the association between e-cigarette use and discounting is weaker than for cigarettes. Okay, so we know that discounting is cross-sectionally and prospectively associated with smoking and other health behaviors. So the question now is, first, how do we change discounting? And second, does that change in discounting impact health behavior in a meaningful way? So if changes in discounting correspond to changes in health behavior, then that may provide, A, even stronger evidence for this functional relation between those two variables, but more importantly, it may provide or may suggest novel intervention strategies. Sure.
What do we know now about the actual health effects long-term of e-cigarettes, or do we not have data yet?
Estimates vary pretty wildly. We're not going to know for a while. They're not good for you. But in terms of, and that's where the debate about the harm reduction strategy comes in, is that at what point do we say, if, for this individual, maybe it's more effective, or maybe it's better for them if they switch, whereas for somebody who's more likely to quit or who smokes less or is, it's a little bit of a gray area. But I think generally there's a consensus that they are safer. In terms of what their long-term effects are, we're not going to know for a while. Yeah. That's an unfortunate natural experiment that's happening, though. So how do we change discounting, and does it have a measurable impact on health behavior? The intervention I examined most thoroughly to change discounting is what we call episodic future thinking, or prospective thinking, and it essentially refers to cognitive simulation of events that might occur in one's personal future. So to some extent, this is something we all do, sort of imagining the experience of an upcoming job interview or a wedding or another personally significant event. It sort of helps us guide our behavior and make plans for the future. But some individuals are much better at this than others. Some individuals do this a lot more than others. And there's substantial evidence that the capacity for EFT relies on episodic memory, as counterintuitive as that may seem. But in order to sort of project ourselves into the future, into a simulation, we sort of have to retrieve and recombine past experiences in order to project and to create that novel simulation. So we have had to have experienced similar episodes in the past to simulate an upcoming event. And because of that link between episodic memory and episodic future thinking, the most common control condition is what we call episodic recent thinking, or ERT. And that's essentially, instead of imagining the future, they vividly imagine events, real events that occurred in the recent past, so that both groups are thinking episodically, but only the episodic future thinking group is thinking prospectively. First study that I did, we had 42 cigarette smokers, and they were assigned to either an EFT or episodic recent thinking, ERT, control group. They first completed experimenter-guided event generation task that is something we do to extract highly vivid, detailed possible events and descriptions of those possible events of the future. So something we get pretty often, things like weddings, parties, reunions, getting promotion, things like that. Those things are pretty common. But we also get relatively small events like dinner with family or friends. So these don't have to be big events. And in fact, a lot of the populations that we examine don't have a lot of these events, big events occurring in their life. So it works pretty well with relatively minor events too. And after that generation task, they completed delay discounting and cigarette self-administration tasks, and we presented text and audio cues reminding them of those events and prompting them to engage in episodic future thinking or control thinking during those tasks. Yeah, that's what that said. So these are the data. These are delay discounting. This is the actual curves, not K values, but delay and then discounted value of $1,000. We said the EFT reduced delay discounting, that it increased valuation of delayed rewards. And in the cigarette self-administration task, it also decreased significantly the number of puffs they could earn during that cigarette self-administration task. So essentially, they're in a booth for 60 minutes at a time. They could smoke as much or as little as they want, and all they have to do to signal that they want to smoke is pull a small response plunger, and then they can have access to a cigarette, to a single puff from a cigarette. So here we have evidence of this experimental link between these two variables. We know smoking and discounting are correlated. Here it seems like if you change one, then you get concomitant changes in the other, which is again consistent with this functional relation between variables and sort of moves beyond the simple cross-sectional data I showed earlier and begins to get at causation. And in a second study online, participants were again assigned to either EFT or control groups, and they completed delay discounting tasks after an event generation task, as well as a cigarette purchase task. We saw that EFT, again, reduced delay discounting. This is K value in the EFT group compared to the ERT group. And the cigarette purchase task, this is cigarette price. This is the quantity of cigarette purchase. It also reduced demand for cigarettes. So this is in the same direction as the cigarette self-administration task I showed you a second ago, but hypothetically online. Turning from tobacco use to another health behavior, or sort of more accurately, a collection of health behaviors like physical activity and dietary intake, we can look at the association between delay discounting and diabetes risk behaviors and conditions as well. So prediabetes is a condition of elevated blood glucose that in the absence of intervention is likely to transition to type 2 diabetes. And of course, in that case, the patient will experience all the short and long-term complications associated with that condition. But interestingly, with lifestyle changes like diet and exercise and weight loss, prediabetes can transition back to a state of normoglycemia. But unfortunately, behavior change, for all of us, but for certain of us more so than others, behavior change like this is hard, right? Diet and exercise are hard. It's hard to lose weight. Behavior change like this should require some minimal amount of valuation of the future. If you change your behavior today, specifically if that behavior change is hard, then you have to be doing it for the benefit of your future self. So the research question here is delay discounting associated with medical and behavioral adherence in patients diagnosed with prediabetes? And by behavioral and medical adherence, I mean adherence to recommended dietary and physical activity recommendations from their doctors. Participants were 81 patients with prediabetes, and again, this is an elevated range, but not yet type 2 diabetes, and that included we included assessments of delay discounting. We assessed diet by 24-hour diet recalls. We assessed physical activity by accelerometer, and then we also assessed how well they were controlling their blood sugar using HbA1c. Important to note, the HbA1c, this is a measure of glycated hemoglobin. It's within a relatively narrow range. So we're looking for cross-sectional associations between HbA1c and discounting. It's going to be hard to see those associations because HbA1c within the pre-diabetic range doesn't vary that much. But we see these are Pearson R correlations. This is a $100 discount rate, and this is a $1,000 discount rate for HbA1c. We saw a significant association for healthy eating, significant association time spent in MVPA. This is moderate to vigorous physical activity. This is how active they were, again, associated with delay discounting, as well as medication adherence. So this is adherence to hyperlipidemia or hypertension medication. Again, a significant correlation there as well. So what this suggests, not dissimilar from the smoking data, is that delay discounting may be a therapeutic target in intervention for prediabetes, so that perhaps if we change discounting, then we can potentially produce corresponding changes in diabetes risk behavior. So what would happen if you apply that same EFT intervention to the prediabetic population? We already have a preliminary answer to that question. Our frequent collaborators at University of Buffalo, Len Epstein and his colleagues, have shown that an EFT intervention in overweight and obese participants, so not prediabetic per se, but still at risk for prediabetes, reduces eating in what's called an ad libitum eating task. Essentially, you have free access to highly palatable food for 15 minutes, and you can eat as much or as little as you want. And in that scenario, the Episodic future thinking group consumed significantly fewer calories in that ad libitum eating task. So we wanted to see, do we see similar effects in the prediabetic population? So participants were 67 participants with prediabetes. They were assigned to EFT or ERT control groups, and they completed delayed discounting tasks and an ad libitum eating task. I'm going to try to speed through a little bit of the rest of this, but I think you get the point. This is across sessions, baseline without EFT 2 and 3. With cues, we reduced delayed discounting. In the ad libitum eating task, there's a directional difference, but it wasn't significant. This could have something to do with the sensitivity of the task. I think this deserves more follow-up, but it was in the right direction. However, followed this up with an online study with 140 overweight obese participants, again, not pre-diabetic, but at risk for diabetes, assigned to EFT or ERT control, and they completed a discounting and a food purchase task. We reduced delay discounting, and we reduced food purchasing. So again, more evidence that if you change discounting, you have a concomitant effect on the behavior with which discounting is correlated. Before I talk about the clinical implications of this EFT intervention, I want to touch briefly about the work I've been doing recently in collaboration with Jen Vaughn with BRCC and the School of Medicine. And that's looking at the same discounting measure and EFT measure in breast cancer patients. So hormone-responsive breast cancer accounts for nearly 70% of diagnoses of breast cancer. What is hormone-responsive breast cancer? There are sort of estrogen and progesterone receptors in and on breast cells. And the receptors pick up those hormones and then tell the cells to grow. When there's cancer, problem is those same receptors can pick up those hormones and tell the cancer to grow. So the standard of care for hormone receptor positive breast cancer is after primary treatment with either surgery, radiation, or chemotherapy, or a combination of 2 or more of those, that participants are put on oral adjuvant anti-hormone therapy for what used to be 5 years is now more commonly 10 years. So it's a long-term medication regimen. So these are things like selective estrogen receptor modulators like tamoxifen or aromatase inhibitors like Arimidex. And those effectively increase the chances of long-term survival. They reduce the chances of cancer recurrence. The problem is between 25 and 50% of patients don't adhere optimally. Either they take it too little, they don't take it often enough, they stop taking it too early. 5 to 10 years, that's a long time to take a medication in the interest of possibly reducing your chance of cancer in the future. So in order to adhere to the long-term medication regimen like that, specifically if there are immediate side effects, requires some valuation of the future. At least that's the hypothesis. So again, simply research question is delayed discounting correlated or associated with medication adherence in breast cancer patients? And if so, can discounting be improved with EFT in this specific population? Ongoing study, 26 thus far, projected N is going to be 100. They complete delay discounting tasks at baseline as well as following or during an EFT or control intervention. These are briefly data. This is for $100 and $1,000 discounting. This is a discount rate, and this is percent adherence assessed by pill count. So they bring in their medications. We count how many they're supposed to have based on when it was filled. It's a pretty striking effect. It's 26. It's small n thus far. I'd be surprised if it continues to be this strong. And in fact, these are just simple correlations. Once we start to partial out some variance from demographic factors, the magnitude of this is probably going to be reduced. But still, it's encouraging that we're seeing an effect this early and such a strong signal. For EFT, this is baseline, and then with cues, with the episodic future or control cues, we see for $100 and $1,000 that EFT is reducing delay discounting. So again, pretty consistent, even though this is not necessarily a pathological, or not at all, a pathological population, and we see pretty normative levels of discounting in this population, they're still sensitive to the effects of EFT, so there's still room to improve. Future directions, briefly, mainly adaptation of EFT methods for use in clinical treatment. So from an experimental standpoint, it's been very helpful that we can, in the lab, know how to push delay discounting around to know what the effects of that manipulation is on the behavior with which discounting is correlated. From a clinical perspective, that's not very useful. But can we adapt these EFT methods for use in the real world to produce meaningful behavior change? That's the main question. I think we're asking that across a couple of different venues. One, our frequent collaborators at the University of Buffalo actually ran a small N pilot feasibility study with overweight and obese participants in which they implemented EFT in the natural environment. So participants were prompted to engage in EFT daily before meal times and during high-risk situations for a period of 4 weeks. And what they showed there is that EFT actually did reduce the number of calories consumed per day, as well as produced greater weight loss over that 4-week period. So there's some evidence that it is kind of promising. It's a small trial, it's a relatively brief period of time, but there's some evidence that you can adapt these methods to produce meaningful behavior change. So our question is, can remotely delivered EFT be used to help, back to prediabetes, to prevent the transition from prediabetes to type 2 diabetes? It's a small, relatively low-cost intervention. Can participants be engaged in EFT to improve some of these health behaviors that lead to type 2 diabetes? Also, in collaboration with Drs. John Eppeling and Mark Greenewald at Carilion, we're asking, in a type 2 diabetic population, in those who've already been diagnosed with type 2 diabetes, can remotely delivered EFT be feasibly delivered and used to improve diabetes management? And depending on the results of that breast cancer study, can it be used to improve medication adherence and breast cancer survival? And that is it. Thank you.
Just got a couple of minutes for questions, but please, if anyone has any questions.
So I've already asked a couple about that. So I'm interested in the kind of the neurobiology that explains some of this, and I realize you can't give me definitive answers. I'm just curious what you think. So from what I've learned before about delayed discounting and changes, I often go back to what I've heard from Warren and you and others about effects on working memory, for example, relationships. And so when I think about it, I think a great case is your pill-taking behavior for hormonal treatment or any hormonal treatment for breast cancer. It sounds like a great candidate to explore that. That is, I presume, I don't know how often one takes the pills. Maybe it's once a day, every morning you got to get up, take the pill. You remember to do it, you don't remember to do it, you cue off something else. So I'm interested in what you think might be the intervening, if indeed that is what's going on, what the intervening steps might be. In other words, to me it's very cool to say episodic future thinking contributes to that. It's even cooler to know how it does that.
Right.
And even at a higher level, what I'll call, I don't know, cognitive neuroscience level, not down to neurobiology. What do you think is going on there?
Right. So with working memory, there's also prospective memory, which is a little bit different than working memory. So remembering to do things in the future. I think that's a form of memory that may be more relevant for medication adherence. Specifically, if a patient knows that he or she is supposed to take a medication at 8 o'clock every morning, some days he or she remembers, some days he doesn't. That's more of a failure of, at least in our view, or my view, prospective memory. So in that way, EFT may be improving prospective memory, although we don't know because we haven't tested that. But in terms of working memory, that's also possible that working memory is involved. Whether the mechanisms, and I'll talk a little bit more about this tomorrow at the Chalk Talk, but what the mechanisms may be underlying this, because we see, in the laboratory, we can see we change discounting and produce this seemingly therapeutic effect on smoking or eating or whatever. What the precise mechanism is, I think we need to drill down a little bit more, because the surface level is that we're changing valuation in the future, that there's a black box in there somewhere, changing evaluation in the future, and then somewhere in between there, making them more concerned about their health. It's probably a little bit more complicated than that, in that there are probably other mechanisms involved that we're not maybe sensitive to, things like working memory. Does that begin to answer your question?
And just lastly, do you measure, do you get a sense of whether subjects, patients, are aware of the changes in their discounting during the process? Is there some way to query that?
Kind of. I was a little bit concerned of, we've not directly queried that, but early on, I was concerned about demand characteristics, about the good subject effect, like if participants are able to glean what it is that we think episodic future thinking can do, then a participant so inclined may be able to conform to that hypothesis just out of social desirability or something. I did examine that in some detail, actually, in the study I showed you earlier, the online study. Does this approximate an answer to your question? So I have a supplementary slide somewhere in here. So here we go. The online study where we looked at EFT and then cigarette demand. Afterward, I asked them, I explained to them what an experimental group is and a control group is. And I said, rate the likelihood or the confidence that you were assigned to the experimental group. And both groups rated themselves about 62%. So neither of them knew with any great certainty that they had been assigned to the experimental group. I also asked them to describe the purpose of the study. I primed them with a statement and said the purpose of the study is to see ... and they filled it in. We rated them for accuracy, either entirely inaccurate, partially accurate, or entirely accurate. There we see some greater expectancy about the purpose of the study in the EFT group, so they know we're intending discounting to change in some way. But if you include these codings as covariates in the primary analysis, then the effects of EFT are still significant. So even controlling for this possible good subject effect, then you still have effects of EFT remaining. And in fact, I think the strongest evidence for the absence of a demand characteristic is the fact that at least the pilot study that they ran at the University of Buffalo produced real behavioral change in the natural environment. It's harder to please an experimenter when you're actually changing your behavior and exercising more and losing real weight. Yeah.
Okay. I'm curious about the EFT intervention. You said that the subjects would be allowed to sort of conjure their own future thing that they're thinking about.
Mm-hmm.
It impresses me that the magnitude or the importance of those could differ. You said the investigators don't necessarily control that in one way, and some patients don't have a real important event that they're imagining, and some do.
Yeah, and we have, Lexi's smiling, we have gone back and forth about how specific this has to be. Does it have to, because typically this is general EFT content. We don't try to regulate what they're thinking about, only when they're thinking about it. Theoretically, if in a health behavior change study, if you make them think about health goals, for example, that would make sense that might be more effective at changing behavior. If everyone comes in with a health goal and they vividly imagine weighing 30 pounds less in 6 months or being able to fit into their wedding dress or whatever. We and our collaborators have run a couple of those studies. There's a little bit mixed evidence, but right now the preponderance of evidence suggests that it doesn't have to be specific to any event. It could just be a general activation of future thinking or general shift in time perspective is what we're after. I think there are a lot of the mechanisms, though, underlying this that we still need to get at. That's a good question. Yeah.
Great, thank you.
Yeah.